Welcome to the BA2 Plus Texas Instruments Calculator tutorial. The BA2 Plus calculator is one of the calculators permitted on the CFA, FRM, CAIA and many other financial exams. This video will help you learn some basic functions used in the subject of quantitative techniques, specifically time value of money, discounted cash flows and basic statistics. We will cover the basic setup of the calculator, like for example the number of decimal points that you would like to view while using the calculator, setting the default compounding frequency, converting the stated annual rate into the effective annual rate using discrete and continuous compounding, calculating the future value and the present value of a single sum of money, computing the periodic rate given the future value and the present value, computing the present and the future value of an ordinary annuity and an annuity due, computing the net present value of an unequal cash flow, the internal rate of return, and the basic statistics such as standard deviation, correlation, and some other functions as we will go along. Your calculator looks like this. Let me first take you through the basic functions of the calculator, the basic buttons that you will be using. This is the on-off button, the down and the up arrow keys, the cursor keys like in your keyboard on the computer, the enter button, CPT stands for compute. Second is like the shift button on your computers. If I press second and CPT, I am actually pressing second and quit. Similarly, if I were to say second and clear work or second and clear TVM. This here is the CF button, which stands for cash flow. We will use this button to calculate the net present value and the IRR functions. This here is the backspace key. The next row is extremely important and we will use it extensively in our time value money calculations. N stands for the number of payments or the number of compounding periods, depends what's given on the question. IYY stands for the interest rate per compounding period or the periodic rate. PV stands for present value. PMT stands for the annuity payments or the periodic cash flow. And FV stands for the future value. The rest of the functions are like that of a normal calculator, and we will introduce some of them as we go along this presentation. The first task we have in our hand is to calculate the effective annual rate given the stated annual interest rates using discrete compounding. I hope you're familiar with this formula, which is the future value is equal to the present value 1 plus the stated annual interest rate divided by m, which is the number of compounding periods, raised to the power of m, and n here stands for the number of years. We are going to be using this part of the formula to calculate the effective annual interest rate, which is the effective annual rate is equal to 1 plus the periodic rate. The periodic rate is equal to the stated annual rate divided by m, as I said, number of periods, raised to the power m minus 1. We don't really need to use this formula to calculate it because the calculator has an inbuilt function to do so. So let's have a look how we do that. So we have the stated annual interest rate given to us as 12%. The compounding frequencies given to us as 1, 2, 4 and 12, and accordingly the effective annual interest rates have already been calculated. In the table below you will see the buttons to be pressed to calculate the effective annual rate given the stated rate. So let's try it out. So let's use the iConvert function to convert the stated annual interest rates into effective annual interest rates. Press the following buttons. Second, iConvert. You see on the calculator screen the nominal rate is currently 0. Let's punch it in. We put it as 12 and enter. Press the up arrow key. This gets you to C by Y. C by Y stands for the number of periods in a calendar year. So here we get about, let's do the semi-annual rate. So we said 2, enter, the up arrow key. Now I can simply press the compute button to calculate the effective annual interest rate. So given the stated rate of 12%, I've been able to calculate the effective annual interest rate of 12.36% for a semi-annual compounding. If the compounding was quarterly, I can press the down arrow key and change the compounding period now to 4. So we simply say 4, enter, go back to the effective annual interest rate and simply press compute again, and I get 12.55%. I can again change it to monthly as well if I want, so press the down arrow key to go to C by Y, put 12, go back to effective, and compute the effective annual interest rate as 12.68%. So it's a very simple process to calculate the effective annual interest rate given the stated rates. Now, you could do the other way around as well. If, let's say for example 12.68 was the effective annual interest rate, and let's assume for a minute that 4 was the compounding period, we would calculate the nominal rate as follows. Simply press the compute button and you're done. So you've already just entered 12.68 as the effective annual interest rate, the compounding period as 4, and you've calculated the 12.1204% as the nominal rate. Now this calculation was done for discrete compounding. What if the compounding was continuous? In case of continuous compounding, the iConvert function does not work. We will have to manually calculate the effective annual interest rate in that case, using the formula of e raised to the power of r minus 1. And the way to do that, on your calculator, you find this function here, which is e raised to the power rx, which is written right above the ln button. Now, the way to calculate this would be, you press r, which is in this case 12%, so 0.12, and you would like to press e raised to the power x. So for that, I will need to first press second. You can confirm that the second button is pressed by having a look at the screen right here, and then press e raised to the power x. As soon as you do that, you get 1.1275. Now this amount already includes the principal of 1, which was also invested to earn the 12%. You subtract out the 1 and multiply it by 100 to convert the answer into percentage terms. So the actual effective annual interest rate is 12.75% approximately. It's worth noting that the effective annual interest rate is increasing as the number of compounding periods are also increasing. So for an annual rate, the effective annual rate and the stated rate were equal, but with continuous compounding, the effective annual interest rate was the highest possible at approximately 12.75%. The next function that we would like to learn on this calculator would be to use the TVM calculations and calculate the future value and the present value of single cash flows. Let's try this question right given here. It says compute the future value of $1,500 investment at the end of 4 years if the annual interest rate is 10%. Now, before you use the TVM calculations, before you use this row, as a rule, always make sure that you clear the memory of the calculator or the TVM function. So to do that, you need to press the following buttons, second and clear TVM. This is to ensure that the memory of the TVM calculations is clear. Now, let's punch in the values. So we say 1500 is the present value, 4 is N, 10 is I by Y, and I compute the future value. You would have noticed that the order in which you enter the present value, the I by Y or N, doesn't matter. The second thing to notice is that the future value has come out to be negative, which means that the present value was an inflow, whereas the future value is an outflow. The calculator assumes that one of the cash flows has to be an inflow and the other has to be an outflow. Only then is there a rate of return being earned. What about if there's a cash flow in the future and I would like to calculate the present value of that today? So we have another question which says compute the present value of $2,000 investment at the end of 3 years if the annual interest rate is 10%. Now, let's first, as always, clear the memory of the calculator of the TVM function and punch in the values. So we say 2000 is future value, 10 is I by Y, 3 is N, and we can compute the present value. And in this case, it comes out to be 1502.6296. This again, the present value is negative because I entered the future value as a positive number. Just to recheck, if you want to, we can enter 2000 as a negative number for future value and calculate the present value and it comes out to be a positive 1502. Notice in this last calculation I did not clear the memory of this TVM function, so n and I by y were already stored. What if we've been given the present and the future value and we need to calculate the periodic rate of return? In this case, I would need to punch in the present and the future values and the n and then compute the I by y. One thing we have to watch out for: one of the cash flows has to have a negative sign here. Only then would there be a periodic rate of return. So in this case, 1500 is the outflow and 2000 rupees is the inflow. So let's punch in those values. But before we do that, always clear the memory of the calculator, the TVM function. 1500 is the negative number of present value, 2000 is future value, 3 is n, and we compute I by y, which comes out to be about 10.06%. Now let's get on to the next topic, which is calculating the present and the future value of an ordinary annuity and an annuity due. For an ordinary annuity, we need to first understand there are equal cash flows happening at equal intervals for a certain time period. So we want to calculate the present value of all these three cash flows as of day to day. For that, we can use the PMT function, which stands for equal cash flow payments, and calculate the present value in one single shot. So let's try it out. Second, clear TVM to clear the memory of the calculator's TVM function. Punch in the values. 1000 is PMT, 8 is I by y, 3 is n, and simply compute present value. The answer comes out to be minus 2577. So what you're doing mathematically really is you're calculating the present value of these three single cash flows as of day to day, and the PMT function allows you to do that simply in one single shot. What if I wanted to calculate the future value of an ordinary annuity that pays the $1,000 at the end of 3 years if the discount rate is 8%? This question is represented in the timeline as follows, where the $1,000 is being paid at the end of first, second, and the third year, and I would like to calculate the future value also at the end of the third year itself. The way to do that on the calculator would be, we would say, second, clear TVM, to of course clear the TVM function on the calculator. Now punch in the values of 1000 being the PMT, 8 being the I by y, 3 times is the cash flow being received, the number of times the payment is being received, and compute the future value, which comes out to be 3246.40. Notice that the $3,000 invested at the end of first, second, and the third year at a rate of 8% per year is yielding 3246.40. Mathematically, what we've really calculated is $1,000 invested at the end of first year is earning interest for 2 years, $1,000 invested at the end of the second year is earning interest for about a year, and the $1,000 invested at the end of third year is not earning any interest, because this amount is being invested right at the same point of time when the future value is being calculated. Let's now move on to another interesting topic, which is called annuity due. In this case, the cash flows come in one period earlier as compared to the ordinary annuity. So if you compare this timeline with the ordinary annuity timeline that you saw on the previous slide, now the cash flows are being received at 0, 1, and 3. And accordingly, the question is also structured the same way, which says calculate the present value in annuity due that pays $1,000 at the beginning of next 3 years if the discount rate is 8%. So the first cash flow is coming at the beginning of the next year, which is actually today itself. Now, notice I wish to calculate the present value also at time 0. So mathematically what I'm trying to do is $1,000, which is today itself, I don't wish to discount that. $1,000 which is happening at the end of first year, I would like to discount that once. $1,000 which is happening at the end of second year, I would like to discount that twice. Now, mathematically, present value of an ordinary annuity multiplied by 1 plus r will actually yield the present value of an annuity due. So the way we can calculate this annuity due calculation is we can assume for a minute that the calculation is like an ordinary annuity, and in the last step we can convert the ordinary annuity into an annuity due by multiplying by 1 plus R. So the way to do this on the calculator is second clear TVM, 1000 PMT, 8 is the I by Y, 3 is N, and we compute the present value. Now this present value is only the present value of the ordinary annuity. To convert this into annuity due, I need to multiply this by 1 plus R, which is 1 plus the periodic rate. So we multiply this by 1.08, and in this case we get 2783, and that's the present value of the annuity due. Always remember, the present value of the annuity due is larger than the present value of the ordinary annuity by a factor of 1 plus R. Now let's turn our attention towards calculating the future value of an annuity due. We have a question. It says, compute the future value at the end of 3 years of an annuity due that pays $1,000 at the beginning of next 3 years if the discount rate is 8%. The question is represented here on the timeline. The $1,000 is being received at the beginning of the first year, which is at time 0. It is also being received, the $1,000, at the end of the first year, which is also the beginning of the second year, and $1,000 again at the end of the second year, which is the beginning of the third year. And we wish to calculate the future value at the end of all the 3 years. Now, way to do that is, first, as always, second, clear TVM to clear the memory of the TVM function, 1000 being the PMT, 8 is I by Y, 3 is N, and we compute the future value. Now this future value has been computed at the end of the second year. It's worth noting that the calculator, when it is in the end mode, calculates the future value at the same point of time when the last cash flow was entered into the account. So therefore, this number of 3246 has been calculated at the point of end of second, while we want the answer to be calculated at the end of third. In order to take the cash flow from second to third, we need to multiply this by 1.08. The same principle that we applied in the previous case of the present value itself. So we multiply this cash flow by 1.08, which is 1 plus R, to calculate the future value at the end of third, which is in this case 3506. So that completes the TVM part of our calculations using the N, I by Y, PV, PMT and FV part of the calculator. We will shift our attention towards now the other functions such as cash flow, which will help us to calculate the NPV and IRR. Now, here we're going to calculate the NPV, which is the net present value of an unequal cash flow. Now, here on the timeline, we have represented the 1700 negative, which is an outflow, 300, 250, 950 and 950 being inflows received at 1, 2, 3 and 4 respectively. Now these are unequal cash flows and we cannot use the PMT function which we had done in the previous case while calculating future value and present value. Now we will have to use the cash flow function and we will see how we can go about that. So let's start this out by pressing the following buttons. CF, second, clear work. Now what does that do? That just simply clears the memory of the cash flow function. Your calculators are actually pretty smart. They have different slots of memory for different purposes. The cash flow memory has to be cleared separately by using the buttons of CF, second, clear work. Now the memory of cash flow has been cleared. Now we punch in the values of the cash flows here and then calculate the net present value and the IRR of that. Now, before we punch in the values, I would like you to visualize as if you were working on an Excel sheet. On an Excel sheet, when you punch in the value and press enter, the cell automatically shifts onto the next cell below that. Your calculators are probably not as smart as that, so you need to bring it to the next cell when you press enter. So let's see how we go about that. So let's punch in the first value, which is 1700, negative, enter. So the CF0 has been entered to as being the negative 1700 cash flow. Now we'll press the down arrow key to come to the next variable, which is C01. C01 happens to be the cash flow 1, which is 300. So let's punch in that. So 300 enter. Again, we'll press the down arrow key. As soon as we press the down arrow key, we see a new variable coming in, which is F01. Now F here stands for the frequency, and that by default already is 1. The 300 cash flow is happening only once in this timeline, and therefore we'll allow the frequency to stay 1, and we'll press the down arrow key once again to come to C02. C02 here is 250, so we'll press 250 and enter. Press the down arrow key once again. We get F02, which is the frequency of 1, by the frequency of the second cash flow by default already as 1. Press the down arrow key once again to come to C03, which is 950. So 950 and enter. Now this 950 is happening consecutively twice. So we can enter the frequency of this cash flow as 2. So we'll just change the frequency as 2 instead of entering another cash flow as 950. My calculator will will assume the next cash flow to be 950 automatically. Now I press enter and have got the frequency of the cash flow in place. Just in case you want to check as to all the numbers are in place, you can press the up arrow key and see if all the cash flows have been entered correctly. Now the cash flows have been entered. Let's calculate the net present value. We press NPV. As soon as I press NPV, the calculator prompts us and asks for the interest rate that is relevant. Interest rate in this question is 10%, so we'll plug in the value. So 10, enter. Press the down arrow key and compute the net present value. So NPV 10, enter. Down arrow key, compute the NPV, and you get the net present value, which comes out to be as 141. Great. Now let's move on to the next topic, which is on calculating the IRR using the same cash flows. So the same cash flows that have already been entered into the calculator. Now I wish to calculate the IRR of these cash flows, and it's very simple. Although I've mentioned all the steps to enter the cash flows, they've already been entered in our calculator. So all that we need to know now is press IRR and compute. So once you've entered the cash flows and then press IRR and compute, the IRR gets computed as 13.05% automatically for you. So all that you need to do is plug in the cash flows as we just did in the previous slide, press IRR and compute, and you're done. So that brings us to the next section, where we are going to try and calculate the basic statistics of a few variables like mean, standard deviation, correlation, etc. So let's have a look as to what the numbers come out to be. Okay. Now we have two variables given to us here, x and y, which are respectively as 3 and 6, -4, 7, 6 and 1. And I would like to calculate their mean, standard deviation, correlation, and see a few more things that will be calculated as for you. Now, in order to do that, we need to first use the spreadsheet function. The spreadsheet function can be used by pressing the following button, which is second and data, which is right at the top of 7. The second and 7, or second as data, you get the spreadsheet function. Now, to make sure again that this part of the memory of the calculator is clear, so we press second and clear work. Now let's punch in the values one by one. 3, enter. Press the down arrow key. As soon as I do that, I come to the next variable for the y, which is y01, which is 6. So we'll say 6, enter. Down arrow key. Now x02 is -4, so we'll say 4, negative, enter. Down arrow key. 7, enter. Down arrow key. 6, enter. Down arrow key. 1, negative, enter. Yeah, we have entered the x and y coordinates. Now we want to calculate their correlation, the basic statistics, and so on and so forth. All that you need to now do is, once you've entered the values, press second and stat, S-T-A-T, stat. This represents a linear equation. We can decide if you want a different equation as well. So we here are looking at a linear equation. Press the down arrow key. It says n is 3. N stands for the number of variables, the number of observations. So the number of observations are 1, 2 and 3 observations. X bar is 1.667. The sample standard deviation of x is 5.13. The population standard deviation of x is 4.18. Mean of y is 4.0. The sample standard deviation of y is 4.35. The population standard deviation of y is 3.55. If you were to draw a line connecting these points, or a regression line connecting these points, the intercept of that line would be 5.1. The slope of that line would be minus 0.68. The correlation between these variables is minus 0.80. We can ignore these couple of variables. These are actually the forecasted variables. This is not relevant for us. Summation of x is 5. Summation of x square is 61. Summation of y is 12. Summation of y square is 86. And summation of xy is minus 16. So there is a lot of variable stuff that can be done with the help of this calculator. Now we move on to the next section of the presentation, where we are going to try and calculate the bond price and accrued interest. So we have a question here. A semi-annual pay bond is priced for settlement on June 12, 2014. It matures on 31st December 2017. The pricing used is a 30 to 360 day convention method with a coupon rate of 7%, redeemable at 100% of the par value for 8% yield to maturity. We need to compute the bond's price and accrued interest. So to calculate the value of the bond and the accrued interest, we need to use the bond function of the calculator, that is second and bond. This here is the default settlement date. We need to change that, and the calculator by default has the date setting as month dot day year. So in this case our settlement date is June 12, 2014. So that happens to be as 6.1214. Enter. We press the down arrow key, and now we enter the coupon rate, CPN, which is the coupon rate. So it says 7. Enter. Press the down arrow key once again. Now this here is the redemption date, which in this case is given to us as 31st December 2017. So we enter that value as month dot, so 3117. Enter. Press the down arrow key once again. The redemption value here happens to be as 100, which is exactly what's given in the question as well. So we'll allow that to stay as what it is. Press the down arrow key once again. Now here it asks us for what is the convention that is being used. Is it actual days or is it the 30 by 360 days? So we want to change this. The way to do that is we say second, enter. Now the convention has been changed to 30 by 360 day count method for the year and month. Press the down arrow key. It asks us, now the calculator asks us as to what is the periodicity of the coupon payment. In this case, is it 2 per year or is it 1 per year? Well, it happens to be 2 per year, so it's semi-annual payment, so therefore we'll let it stay at 2 per year itself. Press the down arrow key. The yield currently in the market is 8%, so we'll say 8, enter, press the down arrow key and simply compute. This here happens to be the price of the bond, and if I press the down arrow key, this here happens to be the accrued interest. 3.15 as the accrued interest and 96.955 as the price of the bond on the settlement date of 12th June 2014. So this brings us to the last section of our presentation, where we're going to talk about some basic miscellaneous functions such as store, recall, raised to the power, backspace, permutations and combinations. The store and recall can be a very useful tool in case you have intermittent calculations between a longer calculation. Let's say, for example, you want to store the number 10. The way to do that is you simply press 10 and say store 1. And later, if you wish to recall it, you simply say recall 1. So store 1 to store the number, and accordingly recall 1 to recall the number. Similarly, you could even store more numbers as well if you wish. So store 2, store 3, store 4, store 5, etc., etc. Another very useful function is the raise to the power. For example, if I want to raise to the power 25 raised to the power of 2 by 3. For this, I could use the store function as well. So let's try and do that. So it says 2 divided by 3, which happens to be 0.667. Let's store this number on 1. Now we'll press 25 and then look at the raised to the power function, which is y raised power x. Y raised power x, recall 1 is equal to. Now this is 8.5, which is 25 raised to the power of 2 by 3. During the process of our calculation, it's possible we might by mistake enter the wrong keys. For example, I wanted to press 15 and by mistake I pressed 14. I can correct my mistake by pressing the backspace key and pressing the right number then. The last couple of functions are on permutations and combination. So we see here NCR and NPR. We can use those functions to calculate the permutation value and the combination. So 10P4, for example, 10 second NPR 4 is equal to, that is the permutation function. And if I wish to calculate combinations, the way we do that is 10 second NCR 4 is equal to. I hope you have enjoyed this presentation and learned how to use the BA2 Plus Texas calculator. If you have any questions, comments on this presentation, or have any doubts about using the BA2 Plus calculator, feel free to email us at info@finguru.in or just visit our website at finguru.in. Thank you.